last code, ECF3NU.
Sir, the screen is visible.
Yes, yes.
Okay. Yes. Excuse me, sir.
Yes.
Have you said something few minutes ago? I just
Shivam, Shivam, can you hear me?
Hello.
Yes. Shivam, is it the same answer you are getting?
Sir, स्टार्टिंग सर डेसिमल के बाद 4 डिजिट सेम है सर.
Okay, so you're getting you are giving the same input.
Let me check sir. 1 minute.
Okay. Sumit, what is your answer?
Sir, did you call my name, Sumit Pandey?
Yes, yes.
Yes, sir. Sir, answer you asking?
Yes, yes.
Just a second, sir.
सर मैंने जो आपने दिया तो वो दिया है सर 2.5.4934.
सर मेरे में 4.2419300, फिर सेकंड वैल्यू है -2.078194 थर्ड वैल्यू है -7.258590.
Okay, so Bhagat.
Yes, sir.
So Sumit, is it the same answer? -2.076 -7.25.
Sir, just a minute, I'm checking, sir. Bhagat, please show your answer. Sir, this right one. Okay. No, sir, slight difference is there. In my one, sir, it is 4.2419 and he's having 4.2406. And second value, my is -2.0781 and he's having -2.0769. And third one is my one -7.2585. And last one, Hagat's value is -7.2596. So variations are there, sir.
Yes, yes. I think the difference is in the latitude and longitude value. He's giving 25.5, 81.85. That's why.
Yes, sir, it must be due to that only.
Okay. So Sunil Kumar, please share your screen now.
Okay.
So Sunil, what is your answer?
4.2419. minus 2.078 or minus 7.25 basis.
Okay. So next to Ruchi Dwivedi, please share your screen.
Yes, sir. Sir, is it visible?
Yes, yes. So what is the value of E and N?
Sir, E 4.24067 and minus 2.076 and U minus 7.25967.
Okay, so can you explain your code? Ruchi,
Yes, sir.
please explain your code line by line. So in the first line, you're defining a function whose name is ACF to ENU, and this function requires input which is phi lambda h, and this function gives the output which will be E, N, and U. Okay.
Yes, sir.
So what do you mean by second line, format long?
Sorry, sir. I don't know. Sir, actually, sir, पूछा था मैंने. सर तो वही लिखा.
हाँ रुचि, पूछना गलत नहीं है, लेकिन पूछने के बाद आपको समझना भी चाहिए ना. नेक्स्ट क्लास में आप पूरा मुझे समझाओगे कि आपके कोड में क्या क्या. ओके.
Sorry, sir.
In next class, you will explain me your code line by line.
Okay, sir.
Okay. So Sumit,
Yes, sir.
what was A there?
What, sir? Which A you are talking about, sir?
In the code which we are seeing at this time in the screen. What is A?
Sir, sir, in screen, sir, only nothing is coming to screen.
Okay. So Ruchi, please share your screen. Yes, Ruchi, please share your screen.
Sir.
Share your screen, Ruchi.
Sir, is it visible?
Oh, yes. So Sumit, what is A in the third line?
Sir, your voice is not clear, sir.
Oh, I'm asking to Sumit, what is A here?
Yes, sir. Yes, sir. Sir, I'm looking at it. Yes, sir. I'm looking at it. Sir, just I'm checking in my code, sir. What value I have taken in.
No, I'm not asking about value. What A is represented.
Acha. Yes, sir. Sir, A is semi-major axis.
Okay. And Sunil Kumar, what is B?
Semi minor axis.
Okay. And Alok Kumar,
Yes, sir.
what are the inputs that are required for this conversion ECF to ENU?
ECF to ENU. Sir, lambda phi and value of reference points are x naught, y naught, z naught.
And
And sir, so that's all, sir. We do not require a value of h for this.
that's okay. What I am asking here, what are the inputs? You are saying that for the reference point, we need X naught, Y naught, Z naught,
Hmm.
lambda naught, phi naught. Okay.
Yes, sir.
Is there any other requirement?
So lambda and phi.
That I have said lambda naught and phi naught. Is there any other requirement?
Mm, sir, x, y, z. And,
X, Y, Z for the point you want to convert.
yes, sir.
So whenever you're defining a function, so
Okay.
all the requirements should be there in the first line. After giving the name of the function, you have to mention here what are the input that you are needed. Okay.
Yes.
So with the phi lambda, if h is there, otherwise no, phi lambda, x naught, y naught, z naught, x, y, z. So these things will be input to this function. Okay. Because if the code which you are looking at the screen, in this code what is happening, we are providing phi lambda h, it is calculating x naught, y naught, z naught, it is defining then x, y, z, then it is going for calculation of the matrix, then you are getting the e and an u. Okay, so you have to provide all the inputs required for any transformation, for any conversion. So here the function will be like E and U equal to EC EF to ENU phi naught lambda naught x naught y naught z naught x y z. Is it clear to everyone?
सर अभी जो लास्ट में बोला अभी थोड़ा सा एक बार और बोल दीजिएगा सर.
एक बार
When you are defining the function, it should be like E and U as the output. It is written already here. So E and U equal to ECEF to ENU. Then in bracket, you have to give all the inputs X, Y, Z, X naught, Y naught, Z naught, phi and lambda.
Okay, sir.
Because this code is being very specific for this point only. You are providing just phi lambda h and it is calculating x naught, y naught, z naught for it, then x, y, z also, and then it is going for conversion. So is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
And Ruchi,
yes, sir.
I'm asking to Sumit for explaining his code. Once he's explaining, please means take a note of that, and so that will help you to understand the code. Okay. So in the next class, you will explain how your
Okay,
code is
sir.
going. So now unshare your screen and Sumit share your screen and explain your code line by line.
Okay, sir. Sir, is my screen visible?
Yes, yes.
So first of all, we have to take 2 points. That one is reference point and another is any point where we have to find the value. Then we have to get the coordinates of these point, and we need three more things. That is latitude, longitude, and height. First of all, sir, we have to get the values of that x naught, y naught, z naught, and x, y, z. Three things. So we'll use the input, uh, this input command. X naught is equals to input in parenthesis, enter the value of x naught. In the same way for y naught, z naught, and x, y, z. And these x naught, y naught, z naught value will be that which we had find from WGS to ECEF, and this x, y, z value will be x naught minus 5. And then we have to we have to get the value of lambda naught, which we had already having from the given values. So we will
One,
use the, yes sir.
the value which I have told you, like x naught minus 5, y naught minus 5, z naught minus 5, it
Yes
was
sir.
just to take as an example. Okay. So
Okay sir.
there may be a value, means this value may be anything. So for
Okay
example,
sir.
we had taken that because the x naught, y naught, and z naught was known to us. And we were thinking that if there is a 5 meter difference in x direction, y direction, and z direction, then what will be that in the direction of E, N, and U? Okay.
Okay sir. Then we need lambda naught value, phi naught value. Then we'll use this again, this command, input command, and in parenthesis enter the value of lambda naught. Then same as for phi naught, then we'll be using this formula. This formula, on the basis of this we'll be creating the matrix. First matrix is ENU, second one is this sin lambda naught 1, and third matrix is x naught, x minus x naught value. Then we have to create this matrix. For creating matrix, we have I've used a variable like b, which is equals to that big first term of that matrix one, like minus sign d lambda underscore naught, then with space for first row, and then for second row, then for third row. Then for that third term of that matrix, I have used a variable like diff is equals to x minus x naught, and the same as this. Then for the multiplication of the matrix, I have used a variable a, which is equals to this first matrix multiplied by second matrix diff. Then for first matrix, that is ENU matrix, we have E is equals to A1, that this value which will be given by this, it will be in three terms. So we are using A1, A2, A3, and we are now at last we are displaying this A value.
The size of the A is 3 cross 1. The first element is easting, and second one is northing, and third one is the up.
Okay,
Okay.
so
Okay. So for the first lab, we have completed all three codes. So if is there any issue with the codes? Is there anyone who has not completed any of the one, first, second, or third?
sir, should I stop sharing?
Yes, yes.
हेलो सर।
Yes.
सर मैंने जो ECF2 यूनिट किया था तो उसमें सर x इक्वल टू x नॉट माइनस 5, y इक्वल टू y नॉट माइनस 5 समथिंग ऐसे डिफाइन किया था। तो सर ये जो -5 कर रहे हैं इसका पर्पस क्या है?
That value we have taken just for an example. At that time, we were requiring the xyz for a location, x naught, y naught, z naught for a reference point, and lambda naught phi naught. Okay, so that xyz may be any point. We are trying to compute easting, northing, up with reference to the known reference point. Okay, so that was x naught, y naught, z naught. I can give you any value of xyz. That x naught minus 5, y naught minus 5, z naught minus 5, that was taken for just an example. If there is difference of 5 between 2 points in x direction, in y direction, in z direction, how that will be denoted in easting, northing, and up?
Okay,
Is
sir.
it clear?
Yes, sir.
Yes. So
Okay.
you can simply think like I have a point. Okay. I have to compute its northing, easting, and north. So I need a reference point on the ground. Okay. So for this point, I know the x, y, and z. But in the reference of the another reference point, which is whose values means coordinates are x naught, y naught, z naught, or lambda naught, phi naught. So how we will do that? Is it clear?
Yes, sir.
Okay. So any other doubt?
ओके सर, लास्ट में एक चीज और पूछना था। जो हमने
Yes.
दो मैट्रिक्स को मल्टीप्लाई किया था, फिर सो ई एन यू को डिफाइन किया था इक्वल टू जो मैट्रिक्स हमारा मल्टीप्लिकेशन इनटू ब्रैकेट में 1 2 3 समथिंग, सर उसका पर्पस क्या था वो बता दीजिए।
Sorry. Ask him please.
सर जो ई इक्वल टू ए ब्रैकेट में 1 ई एन इक्वल टू ए ब्रैकेट में 2 समथिंग, ऐसे हमने लास्ट में ई एन यू को डिफाइन किया है, तो सर वो मुझे कॉन्सेप्ट नहीं समझ में आ रहा है कि हमने ऐसा क्यों किया है।
Means in the code, in the line which was mentioned like a equal to matrix
Yes, sir.
into b, then what we had done e equal to a1.
Yes, sir.
Now just simply think like this, we are computing the value in the a variable, a equal to matrix into second matrix b. Okay, so now three values will be there in a. If you look at the equation, in the left side it is column matrix which is having three values e, n, and u. But when we are multiplying it, we have not defined e and u. So at that time, we have stored the value of e and u in the variable a. So now a is 3 cross 1. So first element will be a in bracket 1. Second element will be a in bracket 2. So in this way, we are just taking the value of e and u from the a variable.
Got it, sir. Thanks.
Is it clear to you?
Yes, sir. Clear.
Okay, let me share my screen. Is it visible?
Not yet, sir. Now visible, sir.
Okay. So when you were looking at the code of the Sumit, it was kind of something a equal to some matrix into b. Is it like that? Arun.
Yes, sir.
So suppose if that matrix is 3 cross, it was 3 cross 3. Suppose it is having the value 1, 2, 3. Okay, it is 3 cross 3 matrix.
Yes, sir.
And it was multiplied by 3 cross 1 matrix, which was x minus x naught, y minus y naught, and z minus z naught. So suppose it is 2, 3, and 4. So when I am multiplying this matrix and this column 1, 2, 3, 4. So let's see what we will get. So you can see in the a variable we are having three values. It is
Yes,
20, 47, and 74. If I want to get means define a variable who's having the name e, then how will I write? I will write E equal to A in bracket 1. So the first element of the A will be assigned to E in the same way for the N and U. Now is it clear to you?
Yes, sir.
Okay. So now today we will discuss about a GPS receiver, which is a handheld GPS receiver. So before that, please let me know what you have studied in your lectures of GPS lectures. So please explain what topics you have covered in GPS class.
Sir, in GPS class, first of all, we had studied about the coordinate system, that Earth fixed, Earth centered, and a celestial, and different types of coordinate system what sir has told. Then, sir, time things, and so now we are learning about the GPS, what kind of GPS signals are there, and in what frequencies they are working, and their modulation stages. These things we have till here.
Okay. So anyone please explain like how GPS works. Arun,
Yes, sir.
so please explain how GPS works.
So GPS mainly work on three fundamentals like first one is space segment and second one is control segment and the third one is user segment. So, sir, in space segment there is a satellite vehicle and through this satellite vehicle the user segment and the control segment they got the signals in L band and when the control segment just upload any kind of data like any information so it's just uploaded in S band and the user segment which have a receiver and the software so this is are the GPS architecture which I'm talking about so these are the fundamentals.
So by means of signals, it is getting signals from satellites. It is doing some processing. You what you told about it was about segment, how we are doing some management. Okay. So how it is working? It is working on the basis of some pseudo ranges, some ranges, or on the basis of some signals. How?
uh, याद नहीं आ रहा सर याद नहीं आ रहा.
Okay, no problem. Sunil Kumar, what you have to explain in a very simple manner, like how you are understanding GPS works.
Yes, sir.
So how GPS works?
Sir, GPS worked receiver and it receive the signal. 1 minute.
Yes, please explain.
Measurement the distance to each satellite by the total time it taken to receive a transmitter signal, sir.
Okay. Uh, One link I have shared in the chat box. Sumit, please confirm that you can download from this link. I have shared a video.
Okay, so. Sir, what is size of this video?
200 MB.
Sorry, sir. Please one more time.
200 MB.
Okay, sir. Yes, sir. It is getting downloaded, sir.
Okay, so everyone please download this video, because in the last 30-40 minutes you have to watch this video, and then I will ask you what you have learned from this video. Okay. Okay, so I was asking about GPS. So if in a very simple manner, if you think, uh, how you do understand that using this measurements from the satellites, the pseudo ranges, and you try to solve to get your positions. So to calculate your position, what do you need? You need pseudo ranges, or you can say ranges from the satellites. Here in the GPS, we are using satellites. So minimum 4 number of satellites you require to get the means observations. Based on that observation, which are pseudo ranges, you try to calculate your positions. There are many errors in the way from the satellite end, also in the atmosphere, also at the receiver end also. So the basic thing, the basic requirement at your end is the receiver, the GPS receiver. Your GPS receiver will connect to the satellite. It will means collect the data, the observation, the signals which are transmitted from the satellite to the receiver. On the basis of that, it will calculate the position. So in this lab, we will learning about a GPS receiver, which is Juno 3B, a product of Trimble. I'm sharing my screen here. We will learn how we can collect the data, how we can process the data, and how we means how we can visualize our data. So is the screen visible?
Yes, sir.
Yes, sir.
Okay. So at the screen you can see it is the Juno 3B handheld GPS receiver. It will collect the data for you. It will process the data. It will give you some positions. But the basic thing, the basic requirement with the GPS, what we want is the accuracy. It will not be so much accurate that you can use it for the means high precision service. So now you know what are the basics of the GPS. GPS is a space-based navigation system which are deployed and operated by US Department of Defense, and it is having 6 orbits, four satellites in each orbit, so total 24 satellites. It is in medium Earth orbit, which is approximately 20,200 kilometer. And what we need minimum 4 satellites, and the orbits are designed in the way we will get minimum 4 satellites at any time on the Earth. So what we require 4 satellites, minimum 4 satellites. We get the observations and we try to calculate 4 things, which are the X, Y, Z, and time. Okay, so this is the Juno 3B. It is a receiver which provides us the accurate positioning within 3 to 5 meters. If you look at the specifications, which is the 5MP digital camera, Bluetooth technology, 800 megahertz processor, and the RAM information, also the flash memory, micro SD memory card, and it's having the high sensitivity GPS bus receiver and antenna. So if you look at the receiver, if you were here in the college, so what you have to do, then you will have taken this receiver and you will go on the ground for data collection, and you can see your results also. So that is not possible at this time. That's why I have shared the video which we have made last time, and you You can see in the video we'll be using that Juno 3B receiver, and we'll be trying to do some experiments like data collection and how we can go for data collection, how we can do the basic settings. So first of all, I will tell you a little about settings, how we'll what are the required settings in the Juno 3B for any data collection, and what are the basic things like data dictionary and all. So that I will discuss here. So this is your Juno 3B. We can see here from the left side, you can see the earpiece, the external GPS antenna port. There are given a button also to control it. We are having the camera button also. You can take pictures for any object you are collecting the data. In the right side, you can see in the right upper side, you can see the power button. This is the button which you will click and it will start. And to control it, we have in the right below corner, you can see the stylus. So using the stylus, you have to operate on this Genesis receiver. On the back side, there is a camera flash, but we are having Juno 3B, so there is no camera flash. And there is camera lens also, and the back cover lock and the speaker. So after collection of every point, there will be some sound like the data is collected, data collection has been done, kind of thing. So how will you operate with this Juno 3B? First of all, to turn on this receiver, you have to press the power key button, which is green button right upper corner. Then you have to see for the time. If it is not right, you have to enter it in the what means the right time, and the clock time also. Sorry, date and time. Then you have to press the last button, which is in Windows button, and then its software will start. So once it started, you have to select the option of TerraSync software. After clicking that, this window will open. You can see here in this window the PR number of the satellites 23, 13, 19, 03, 21. So PR number of the satellites is shown in this sky plot. So whatever satellites will be connected at that time, their information will be given in the sky plot. You can see in the right side, it is written 28-inch. So it is the horizontal accuracy for this receiver at this time when it is having 18 satellites. So this is the accuracy. Then in the left of it, it is the battery status. Then after that, it is for the correction. You can see it is the correction, showing that we are getting the corrections from other systems. Then the number of satellites 18. Along with that, many information you can see in the below side, like northing, listing, MSL, coordinate system, and the minimum elevation, minimum SNR, whatever the settings are have been done. Okay.
Sir, sir, that number of satellite 18, what does it mean? It means that at that particular point, 18 satellites are being observed.
Yes.
Okay.
So before the data collection, you have to do some settings. So in the sky plot, you can see there is a button in the left upper corner. It is status. You have to click on that. You will get the options of the setup. So in the setup, you can see there are options: logging setting, GNSS settings, real-time settings, coordinate system, units, and external sensors. So in logging settings, you will do some settings like how you will collect the data. Like once you are standing at a place with your handheld GPS receiver and you want to collect data. So with how many observations, like you are deciding like at 5 seconds, after collecting 10 points, after taking 10 observations, my points will be fixed. So these kind of setting will be done in logging settings. Then GNSS settings, similarly real-time settings. In real-time settings, you have option to select like you want to get correction from any other sources. So that selection you can do here, and along with that you can also select like no correction you want at this time. So these settings will be done there. So let's see one by one. It is logging setting. In the logging setting, like the first one is the accuracy setting. So how you want to see the accuracy setting. So the first is the horizontal. If you select the horizontal, you can see in the window in the right upper corner, it is written 3.7. So in horizontal, it is the accuracy is 3.7 meter. Similarly, point vertex auto pause count means after how many observations it will means it will fix the point. What I mean by fix here, it means like it will take the 10 observations, and on the basis of 10 observation, it will calculate the position of the point. You can give the antenna height here. If you select it to confirm in allow position update, so after collecting the data, after calculating the position, it will in the sound like data collected, a point stored kind of thing will be there. Along with that, what will be the file name, waypoint name, what will be the style? These things, thing you will have to understand between feature loggings. Style. Okay, so there are two options in style. One is time, one is distance. So if I have selected like in 10 seconds, the point will be stored. This is an option. Or you can decide in every, like you are walking with your receiver, so you decide distance. So in the distance you have decided 1 meter. So after each 1 meter, it will collecting your positions. So second one is the Genesis setting, where you have to provide the receiver port, at which port it is there. So in this is the real-time settings. Here the option of use uncorrected Genesis means no correction will be applied. Use integrated S bus. This is one of the very special feature in this Genesis receiver, the integrated S bus. So you can get the corrections from the S bus. So what is S bus? It is a satellite-based augmentation system. So what it will do? It is a system of some geostationary satellites that will provide the corrections to you. Okay, so differential corrections means what are the corrections in the range or whatever. So to collect your point, they will point the corrections to you. And the one more option is external source, means if you are adding an external source to get some corrections, you can add here. So in the choice, if you want to once you select the integrated bus, you will see there is a your accuracy will increase on the basis of these corrections. Next is the coordinate system. So what coordinate system you are selecting here, like in system latitude and longitude, in datum, in the reference, height table, ellipsoid, whatever you want to calculate here. So next is the units, distance, area, velocity, angle. So these things you can define in this setting. After that you have to click on the manager button, and you have to, because now you are going for data collection, you have to create a new file. So you have to select here in the manager button, and you have to click on new. If you have any existing project, you can click on the existing file also. So once you collect on new data file option will be open. Here you can select what is the file name, what is the dictionary. So I was talking about your dictionary. So in dictionary part, like you are selecting any feature to collect. Suppose you want to collect the location of the poles in the college. Okay, so along with the location of the poles, what else you want to collect with the location? Suppose in the dictionary, you can give the option whenever I am collecting a point, suppose the position of the pole, I need to have the photo of that pole. I want to enter some information of that pole, like the pole is means okay or not, it is working in working condition or not working condition, everything. So whatever you can say here the attribute. So with the feature, you can decide what attribute you want to collect with that feature. So after providing the file name, we'll provide the height, and it is by default it is in the system. So type of the antenna, measure to bottom of the receiver. Then you will get the option of collection, data collection. So in three ways we can collect the data. It is the point, line, and the polygon, which is shown here area. So it is written here point generic, line generic, area generic, because we have not given anything in the dictionary. If you have provided in the dictionary, then you can collect data on your means according to you, whatever you want to collect. You are collecting the line or area or point, and you have decided some attributes also. What kind of it feature it is, like in the points you are collecting the location of trees, then condition of the trees, where it is located. Any information you can add with the help of the dictionary, data dictionary. So if you have to collect the point data, you have to just click on the point generic. After clicking it, it will give the option of giving the comment, the name of the point. Along with that, what you can see in the right upper corner here, because in the logging settings I have decided to what style I have taken, it was time. So if I have given 10 over there, so it will count for 10, 3, 4, 5, 6, 7, 8, 9, 10. Once 10 is there, then the point will be the location of the point will be fixed. Similarly for the line, you have to just click on the line generic, and you have to work with the receiver. So once you are collecting a line feature, line data, you can see here a symbol of drawing some line. You can provide the means the name of the line. Similarly for the area generic also, you have to click here, and you have to try you have to walk over any polygon feature. You will collect the data, and it will be the first and last point will be connected. So how you will plan for the data collection using this Genesis receiver? It is the first you will decide the feature. You will decide the entity, like what kind of feature I want to, what kind of features information I want to collect. So if you selected like this is the feature A, then you will also analyze, I mean, so discuss like what other attributes, what attributes I will attach with this location of the feature. So that's why you will be needed to create a data dictionary. The second thing will be to go to the ground. On the ground, you will collect the data in any form like polygon, line, or point. Then the last one is the post processing. So we have a software which we call GPS Pathfinder Office. So after collecting the data, you can take that data to your office using the Pathfinder software. You will process the data, you will apply corrections, and on the basis of that, then you can export your data in any form, like in shape file, in camel files. So it's an example like how you'll go for the data processing. This information you can see here. It is a point feature, which is the water cooler, and we have decided some attributes like what is the condition, it is working or not, what is the number of this feature, it is 12, which company it belongs to, which company, it is the cat labs it one, and what is the date, what is the time, we have taken the photo also. So this is the advantage of using the data dictionary. So this is the data which we have imported in the Pathfinder office. After that, from this utilities section, you will, oh, 1 second. Yes, in this utility section, you will select the third option. It is the differential correction. After this wizard will be open. We will select them. There are some options like how we want to process. So I'm taking here automatic carrier and code processing. Then you will search for the base from where you want to get the corrections to process your data. So here we have selected the ISC one. Now some information of output folder and output file name, and then it will be done. So after the correction part, you will go for the export to data. So in the export section, you can see there are many options. Here we have chosen here for sample S3 save file setup. So this is the data. So what we have done, we have collected the data for location of dustbins in the college just for experiment, and then we have processed it in Pathfinder office, then exported in the camel. So you can see the location of dustbins in the college. If you click on any dustbin, you can see what are the information which we have collected. This is for the poll actually. So what is the poll number, what is the condition, what is the color, company, date, time. The photo is also here, and the information at the time of data collection, like what is the maximum PDOP, what is the maximum SDOP, and what is the correction type, it is corrected or not. So it is not corrected this time. So what is the rover type, mean or receiver, so it is the Juno series 3. So these all information is given there. This is the data of trees, which was collected by one of your senior, and you can see he's collected data for trees in this line from academic building to the boys hostel. So in this way, means you can visualize your data on the Google Earth or in ArcGIS also. Similarly, this is the information collected for the water cooler. So you can see here the information of the, I think it is the for water cooler. So you can also export in the shape file, and we have shown it in the ArcGIS. Okay. So this was the information regarding how you can use the Juno 3B for data collection and processing, and then after that visualization. So what the video I have shared to you, I think you would have downloaded it. So I'm uploading that presentation also in the chat box. So is that video downloaded?
Yes, sir.
Okay, I have shared that presentation here. So do one thing, in next half an hour, you have to watch that video and you have to learn how to collect the data. Okay. And please raise your hands when you have completed that video. So is there any doubt regarding that, regarding data collection?
सर
Yes.
सर जो आपने वो ट्री के लिए पॉइंट लिया था तो सर उसमें 31 ऑब्जर्वेशन तक आपने इंतजार किया सर वो किस लिए था
31.
हाँ सर जब तक उस पर 31 काउंट नहीं आया फिर तब तक आपने उस पर ओके नहीं किया था जब आपने ट्री को पॉइंट किया था तो
Actually, we had decided that after 30 observations, we will complete the data collection for that tree. It's on you, like how many points you want to take for that observation.
सर तो उससे ये एक्यूरेसी डिफाइन होता है कि कितना ज्यादा एक्यूरेट होगा ऐसा कुछ है कि बस
Yes, you are having more number of observations that will definitely affect your accuracy.
तो सर जैसे कि अगर लीनियर ऑब्जेक्ट मैं अगर कर रहा हूँ तो सर उसके लिए वैसे कुछ डिफाइन करना होता है कि कितने पे पॉइंट पे लेना चाहिए या फिर उसके लिए कुछ अलग सा है रूल
लाइन के लिए
यस सर
लाइन की सेटिंग्स में आपके पास ऑप्शंस होंगे कि एक पॉइंट को डिफाइन करने के लिए कितने ऑब्जर्वेशंस चाहिए। तो जब आप जब स्टाइल में डिफाइन करोगे डिस्टेंस लाइन के लिए, तो ऑन द बेसिस ऑफ दैट it will take the observations and it will calculate the position also. Any other doubt?
Yes, sir. What was that DUP, SDUP, SDUP, sir?
Dilation of precision. It is an accuracy measure that depends on the constellation of the satellites. Means how many satellites are there. These are scattered or they are just means in a very narrow view. So that affects your accuracy. If these are scattered, then your accuracy will be good. If these are not scattered, just means clustered, then that will affect your accuracy. That you will study in your lecture about dilation of precision.
And sir, when there was 8 or 10 satellite, there was accuracy of 8 meter. And when the satellite number increased, the accuracy had decreased. That was became to 11 meter. Then you had set it to the real time. Why this accuracy decreased? Why it had decreased, sir? When satellite was increasing also.
That depends on the constellation, that depends on the signal, that depends on the actually errors in that atmosphere, because the signal is hampered by the atmosphere also, in ionosphere, troposphere.
Yes, sir.
So generally it is assumed that with the increase in the number of satellites, your accuracy will increase. But that may happen with the things like there may be some error from the satellite end or in the atmosphere or from your end also, because the clock which we are having in this receiver is not so precise. That's why we are getting that means that very lower kind of accuracy from 3 meter to 5 meter, 10 meter, 20 meter kind of thing.
Okay, sir.
One more thing, I don't know I have included that in video or not. Once you click on the real-time corrections, your accuracy will means increase. It will be around 2 meter, 3 meter kind of thing.
सर
Yes.
सर जो रियल टाइम सेटिंग्स में से दो ऑप्शन थे एक एस बॉस का था और एक अनकरेक्टेड जीएनएसएस का था तो सर जब आपने पहले अनकरेक्टेड जीएनएसएस लिया तो 19 मीटर समथिंग आया था और सर एस बॉस में 7 मीटर समथिंग आ गया था तो एक्यूरेसी तो सर एस बॉस में अच्छी थी तो बट सर जो अनकरेक्टेड वाली जीएनएसएस सर उसका पर्पज क्या है यहाँ
Its purpose when it is collecting a data. Okay, if you want to process that data later, if you want to see like on the basis of zero correction, when you are getting no correction, what will be your accuracy? To increase the accuracy, that option is added in that receiver of SBAS. It will get corrections regarding what is error in the atmosphere, what is error from the satellite in. It will not be actually broadcasted individually. The station which we were having in processing section, I have told you about correction, differential correction. So the objective is to provide some corrections only. Sorry, Arun, what was your question?
तो वो जो दो एस बास और सर अनकरेक्टेड जीएनएसएस था, तो सर उसमें हॉरिजॉन्टल एक्यूरेसी में डिफरेंस आ रहा था। तो
Yes.
सर एस बास में सर काफी अच्छे एक्यूरेसी मिले थे, और सर जो अनकरेक्टेड वाले सर उसमें तो एक्यूरेसी काफी ज्यादा 19 मिली थी सर। तो उसका मतलब क्या है सर? तो अच्छी एक्यूरेसी लेके चलेंगे तो वो देने का मतलब क्या है?
एक्चुअली वो बेसिक है। बेसिक ये है कि आपको सिग्नल्स आप रिसीव करोगे, ऑब्जर्वेशंस होंगे, ऑन द बेसिस ऑफ ऑब्जर्वेशंस आप अपनी पोजीशन को कैलकुलेट करोगे। ये एक फीचर है जो ऐड किया गया है उसमें कि हमें करेक्शंस भी मिल सकते हैं एसपास से। आर गेटिंग माय पॉइंट? एसपास एक डिफरेंट थिंग है जिसे बाद में ऐड किया गया करेक्शंस देने के लिए। करेक्शन मिलेगा तो हमारी एक्यूरेसी इंक्रीज होगी, और अगर आप करेक्शंस नहीं लेना चाहते हैं या जब तक ऑप्शन नहीं था तब तक हम अनकरेक्टेड ऑब्जर्वेशन ही लेके चल रहे थे। It is clear, Arun?
यस सर।
तो आपने क्या समझा मुझे बताइए।
सर यही समझा कि सर जो एस बास से थी सर, तो उसमें हमको 7 मीटर समथिंग की एक्यूरेसी मिली थी। तो उससे सर जितने भी हमने पॉइंट जो ट्री के लिए सर उसकी एक्यूरेसी अच्छी है। अगर हम अनकोरेक्टेड लेते हैं सर तो कुछ हमें अलग से कैलकुलेशन करना पड़ता उसको सही करने के लिए।
अगर हमें एक्यूरेसी इंक्रीज करनी होती बाद में, तो हमें जो ऑब्जर्वेशन उस समय मिले थे उस पर हमें मॉडल सप्लाई करने पड़ते और भी चीज़ें करनी पड़ती। बट अगर हमें वहीं पे ऑन द फील्ड हमें पोजीशन चाहिए, तो उस समय एसबास करेक्शन हमारे लिए एक है फैसिलिटी अवेलेबल है जिसे हम लेके अपनी एक्यूरेसी को बढ़ा सकते हैं। ओके।
यस सर।
ओके। एनी अदर क्वेश्चन?
Sir, can we understand it like the uncorrected data?
Sorry, your voice was not clear.
Sir, I was saying that we can understand it like in this way, that if we at any certain time we don't want any correction and we want that raw data, then we can use that uncorrected correction.
Yes, yes. Any other question? There was the option of nest.
Yes, sir.
Yes, what was that?
So that was for point generation.
In which condition?
Means suppose we are walking in a line for line generation, and we are walking certain distance. At any certain distance we want that that particular point should be considered, then we can go to the option and go to the nest, then point generation for that particular point.
And after collecting that data, we can again continue with outline.
Yes, thank you, sir.
Okay, I think now it is clear how we can use the Juno 3B handle GPS receiver, how we can go through the processing, how we can go for data collection, and what result we can get. Okay. So this was whole about Juno 3B, and If there are any question regarding that, you can ask here. Otherwise, in the next class, we can discuss. Okay. Okay, so